The electricity inside a lightning bolt can reach over 200,000 amps. And less than 1 amp can kill. But I'm going to meet Brian Broaddus, who's built a machine that can recreate the power of a real lightning bolt.
What kind of stuff can you blow up here?
Oh, we can blow up anything.
But I'm going to meet a man who can not only create his own lightning, he claims he's invented a suit that can make humans immune to lightning's deadly power.
The forces of nature shape our planet. But they also have the power to destroy. Mankind is at the mercy of these phenomena. But I'm on a mission to find people who claim they can harness the planet's deadliest forces. They're ordinary people with extraordinary powers. These are the freaks of nature.
Lightning.
One of the most destructive forces on our planet.
Each deadly bolt is hotter than the surface of the sun, and they cause over $3 billion in damage each year.
To demonstrate the power of electricity, I'm heading to Medford, New Jersey to meet the men who are routinely exposed to this deadly power.
Lightning is nature's ultimate display of force.
The electricity within each bolt is so unpredictable and so powerful, there appears no way to harness it. But mankind has been using electricity for 200 years.
With a population of over 300 million here in the US, we depend on electricity to be there at the flick of a switch. To make sure that happens, an elite team of experts puts their lives on the line to keep the power flowing.
Known as linemen, this team serviced the highest voltage power lines in the US. And amazingly, they do it from the air using helicopters.
We are highly skilled, highly trained linemen dealing with high voltage power.
Flying in such close proximity to so much electricity takes nerves of steel.
You gotta know what you're doing up there. Everyone's gotta be on the same page. If we get too close to a tree, and we say we do go to ground, electricity will go through us, through the helicopter, to the tree, down to the ground. It can kill you.
How can these men work so close to this much power? I've brought in a 100-foot crane so that aerial lineman Paul Cudless can show me how they fix a section of this 230,000-volt power line.
Now, a helicopter this, high off the ground, this close to some wires, that sounds dangerous. It's gotta be. I imagine people do die doing this, so the margin for error has gotta be really, really small.
That's correct. The helicopter blade spinning, makes contact with one of these wires, it'll go right to the ground, and that'll be it, yeah.
So let's just say I reached out and I touched that wire that we're about to fix. What would happen?
If you're not wearing the proper equipment, then it's gonna be the end of Tyler.
The helicopter is now approaching. Normal air safety recommends 150-foot clearance from a power line.
Whoa, whoa, whoa. So close to the wire.
These guys are just inches from the deadly cable. The piloting skills are unbelievable, and I can hardly watch. The lineman uses a metal rod to make the helicopter's chassis part of the electrical circuit running through the power line. But then he does something totally unexpected.
What's amazing is he's actually touching the wire with his hand.
That's correct. It's what we call bonding on. It's becoming part of the circuit. The wire, electricity is going to be running around you. It's like a bird on a wire.
Bonding on to the circuit is actually becoming part of the circuit. When you bond on yourself, the pilot, the helicopter, all that is energized. You have 230,000 volts going through all that.
The pilot must hold the helicopter steady while the lineman performs a vital job.
Why do we need to put these on anyway?
Well, we're actually making a repair. There was a lightning strike and it broke one strand of the wire. So these armor rods, it's like an outer skin, and it actually acts like a Band-Aid, and it fixes the broken strand, so it's like brand new wire.
This potentially deadly operation takes the team almost half an hour.
And that's it!
That's it.
The helicopter linemen demonstrate that the deadly power of electricity can be overcome, but only if you know what you're doing and have the right equipment. But the electricity in the power line is nothing compared to the power inside a lightning bolt. I'm in Santa Barbara to meet a scientist who can create his own lightning bolts.
My search is going to take me to a rather unusual place, a garage, to be precise. But you won't find any cars parked in this one.
I'm heading to Dr. Austin Richards' lightning lab to experience some of his crazy lightning inventions firsthand.
There's no room for a car in your garage because it's full of all sorts of really cool stuff. What exactly do you do in here?
This is a high voltage laboratory where I build machines like Tesla coils, Jacob's ladders, and Van de Graaff generators.
Why the fascination with lightning and electricity?
I'm a physicist by training.
Right.
That's what I have my PhD in. And I got interested in high voltage a long time ago when I was 8 years old. And that's when I first saw a Tesla coil. And I was really intrigued by how beautiful an object it was, even when it was off. And when you turn it on, all of a sudden you're seeing electricity shoot out into the air, just like lightning. I love lightning. I think lightning is one of the most amazing natural phenomena. I mean, it's so unexpected that electricity comes down from the sky and causes destruction.
Like any mad professor, Austin wants to keep his inventions behind closed doors.
All right, so just wear this like a regular backpack.
All right. Got it.
I built this Tesla coil backpack in 1999. As far as I know, I'm a pioneer in making lightning that can be directed in any direction you want.
Oh, yeah. Okay, let's see. Whoa!
I'm firing miniature lightning out of my arm. It's like something out of a science fiction movie.
That's amazing. Let me just do it one more time. I love that. It's just amazing that you can take something that is of nature and kind of, you know, for all intents and purposes, control it and do whatever you want with it, isn't it?
Oh yeah, electricity is an amazing force that we can harness and use for good or evil.
Right.
Austin tells me he has a bigger machine that can produce 100,000 volt lightning bolts.
The higher the voltage from a high voltage machine, the more spectacular the lightning it generates. I've spent many years building larger and larger high voltage machines in this workshop, and I'm able to make lightning bolts that are 15 feet long.
Not only that, he's designed a suit that enables him to touch these high voltage bolts that have the power to kill.
That is quite a serious suit, man. Wow. Are you ready to give this a shot?
Yeah.
Okay. What do you need me to do?
Take the extension cord behind you and plug it in over there
Okay.
into that power strip.
All right.
And put the hearing protectors on first, okay?
Okay.
Without the suit, there's enough power coming from the machine to stop Austin's heart instantly.
So how many volts did you get?
That machine puts out about 100,000 volts.
But 100,000 volts is nothing compared to a real lightning bolt. So I'm going in search of a way to simulate nature's power. Can Austin's suit really withstand a strike of over 2 million volts? I'm in Fullerton, California, where inside this industrial unit is one of America's most advanced lightning research facilities.
Every year, around 50 people are killed by lightning in the US. But what makes this force so deadly? To find out, I'm meeting a lightning specialist to understand the science behind these natural powerhouses.
Brian Broaddus is the man behind this facility. He's built a machine that has the ability to recreate the power of a natural lightning bolt.
First off, what is this place? What can you do here?
This is a lightning test laboratory where we simulate lightning strikes. So we actually generate controlled explosions to try to blow things up.
What kind of stuff can you blow up here?
Oh, we can blow up anything. And in our lab, the voltages and currents that we use are absolutely deadly. You don't want to be in here when it discharges. It is a very loud, big explosion, and you don't want to have anything to do with it.
Well, I love all the technical stuff, but let's blow something up.
All right, let's do it.
Here at the lab, they perform vital safety tests on anything that might be subject to the effects of lightning. And nothing is more exposed than an aircraft.
So the guys are going to show us exactly what this thing can do by simulating a lightning strike on the nose cone of this airplane.
Thanks to the research done in these labs, airplane nose cones now have metal strips to divert any lightning around the fuselage. The strips channel the electricity around the plane in what's known as a Faraday cage effect. They've actually removed the strips to show us what used to happen when a plane was struck by lightning. Brian takes me into a bomb-proof chamber.
Over here, Steve has high voltage power supplies and all the control circuitry that we use. You can look at it as a bucket. It's a great big bucket, and we're filling it up slowly, and then we're going to dump that bucket all at one time.
Okay.
Hey guys, here's the countdown.
All right.
3, 2, 1.
Oh my gosh, that was, I mean, it was just like,
It's
it was
pretty impressive,
like,
isn't it?
like your whole body getting just
Oh,
hammered.
it is. There's a huge shock wave associated with the event.
I've just seen what a lightning bolt can do to a plane's fuselage. But what about a direct strike on the human body? Brian's colleague Steve wires the mannequin so that all the power of a lightning bolt will hit it from above, with no plane fuselage for protection.
What are we gonna hit him with here, though? How much are we amping up here?
The discharge through him will be 200,000 amps. So
Okay.
we're going to put 200,000 amps at about 75,000 volts.
Now, what's gonna happen to our friend in there?
He's definitely going to suffer some catastrophic injuries.
Here we go.
Here goes. Everyone ready?
All right.
Go ahead. Okay?
Okay, should I be sweating?
Yeah, a little bit.
All right.
Countdown.
3, 2, 1. Firing.
Holy moly.
I think I just discharged.
I think he's a little
Aye.
shorter. That really blew up, didn't it?
Wow.
I didn't expect it to go off quite that well, but
Is it okay to touch him? He's not
Yeah.
getting too hot? Oh, my
no,
God.
take a look inside.
Oh, Manny.
See how it's all charred?
In the real world, is this the kind of thing that we would expect if you were hit with this kind of power?
Normally, the current going through your body superheats the water in your body and causes explosions internal to you. So, yeah, that's a very typical response.
This is what happens when you get a direct strike by a bolt of lightning.
Now that I've seen what Brian's lightning machine can do to a human, I'm going to use it to put Austin Richards' suit to the test, to find out if it really can make a human lightning proof.
2, 1.
Austin Richards is an inventor who claims to have built a suit that could make him lightning proof. Before we put it to the test, I'm about to feel the power of a lightning strike for myself. It's said the safest place to be in a lightning storm is in a car. Here at the DNB Lightning Research Facility in California, they say they can prove it. This time, there's no mannequin, and I'm gonna sit in the car while it gets repeatedly struck. The metal frame of the car should protect me in the same way as the plane, but saying that is one thing. Doing it is quite another. And engineer Steve Cook is going to pull the trigger.
What should happen to the car when it gets hit by a bolt of lightning?
The lightning will hit the car, attach to the metal, travel through the metal, and to the axles and the tires and disperse to the ground, so all the current flows to the vehicle and not into the people sitting inside the car.
Like a plane, the car will create a Faraday cage, channeling the bolt around me to the ground.
So how powerful is this lightning strike going to be?
We're going to hit this with about 2.5 million volts, and this is about as much power as humans can create in order to simulate a lightning event.
So theoretically, I can get in this car
Yes.
and we can do this test and I'll be fine.
Most likely, yes.
Steve says the car is the safest place to be in a storm. But as he fires up the lightning machine, I'm not so sure.
So I'm about to get hit with 2.5 million volts of lightning anytime now. I think it's the anticipation that's the worst. 3, 2, 1. Ah! Son of a...
Hey, there it is again. Okay.
Jeez. Ah!
I just survived 7 2.5 million volt lightning strikes in the car.
All right, well, that was quite the shock, no question about that. But here I am, I'm fine. Car seems to be fine. So let's see if she starts up. Steve is right. Safest place to be in a lightning storm? Right here.
The solid metal car protected me, but I want to see if Austin Richards' wire mesh suit can withstand a bolt of this lightning, and in theory, make people immune to lightning's power. If it works, there is one place where they need lightning protection more than anywhere else. Here in northern Venezuela, there is a legend of a place where they have the most lightning on Earth.
It's the most powerful electrical phenomenon on the Earth.
At Lake Maracaibo, there is a 10-hour lightning storm almost every single day.
Porque hace muchos años, que las personas mayores, los papás de nosotros, los abuelos, nos decían que el relámpago de Catatumbo, cuando ya ellos tuvieron conocimiento, ya existía, ya ellos lo veían.
There are many theories why so much lightning occurs here, but each bolt is created in the same way as anywhere else.
It's formed by static basically building up in the clouds and gets to a point finally where it'll actually break down through the air and discharge down to the earth. I'm just in awe of Mother Nature's ability to generate such huge voltage and currents.
In 2010, after an extreme drought, the lightning disappeared for 2 months. The first time it's believed to ever have stopped since 1906. Every one of these 20,000 strikes a day has the power to kill hundreds of people. Back at this lightning facility, we're now going to test Austin Richards' wire mesh suit to see if it really could protect a human from the power of nature. On my journey to find people who can harness lightning, I've witnessed linemen touching power lines in midair with their own hands. I've discovered what it feels like to be struck 7 times by over 2 million volts.
3, 2.
And I've seen what a direct lightning strike can do to a human body with no protection. I'm now going to test Austin Richards' wire mesh suit to see if it really could protect him from nature's most destructive force.
Austin claims that his suit can withstand a 2 million volt blast of lightning. Now that's enough to kill someone instantly, but if he's right, he'll have invented his very own superpower.
Austin believes his suit is lightning proof, but the guys at the lab know just how deadly this lightning machine is. So we're going to have to test it using another mannequin.
And you've never had a chance to to hit this thing with 2 million volts, right?
No, never.
How exciting is that? Just from your perspective.
It's really exciting because it's going to discharge a hell of a lot of energy in a very short time into the suit, and I've never done that before. Theoretically, it should be okay, but in practice, anything can happen.
What do you think is going to happen?
I'm not sure exactly. I hope that the suit survives, but I think this is really the closest that the suit will ever come to being hit by actual lightning.
The generator is now charging up to over 2 million volts. Like a car, the outside of the wire mesh suit should create a Faraday cage, channeling the power of the bolt down to the ground. Despite a direct strike of over 2 million volts, the mannequin is completely unharmed. Now it's Austin's turn to suit up and take on a bolt of lightning that has the power to kill him instantly. And I get to push the button.
Okay, what do I got to do here to make this happen?
Well, what I'm going to do, I'm going to turn the voltage up.
Okay.
So I'm going to tell you to go ahead and press the button.
Okay, so let's do this thing. Let's fire this up and let's go.
All right.
All right. 3, 2, 1. Here we go. Boom!
Lightning from this large Tesla coil is deadly. The lightning hits the metal suit and it goes on the outside of the suit. I'm completely protected from it. Being able to stand next to very dangerous artificial lightning is like having a superpower.